Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so we have been discussing about the Newton's laws of motion, and in the previous class we have discussed about the Newton's first law. Today we have discussed about inertia. You know what is inertia by now. So today we will be discussing the types of inertia and some practical examples which are related to our daily life situations. Okay, so let us see what are the types of inertia. Basically, see, inertia can be of three types. Inertia can be of three types. What are the three types? Okay, basically inertia can be inertia of rest. Okay, so inertia of rest. What is inertia of rest? You know that this is the property of body by virtue of which a body tries to remain in its state of rest as long as possible until and unless an external force is applied on it. Okay, so this is inertia of rest. Second is the inertia of motion. So inertia of motion, this is the property of a body by virtue of which a body tries to remain in its state of motion until and unless an external force acts on it. It tries to remain in the state of rest. That is due to the inertia of rest. And if it tries to remain in a state of motion, it is due to the property of inertia of motion. And the third kind of inertia is the inertia of direction. Inertia of direction. So what is inertia of direction? See, a body when moving tries to maintain a certain direction. Say when you kick a football, it actually moves in a straight line path if it is moving on a horizontal, exactly plain horizontal ground. Okay, or you must have seen that a car keeps on moving in the straight road path until the steering wheel is turned around. So this is the inertia of direction. Inertia of direction is that property of body by virtue of which a body maintains its direction of motion. It keeps on moving in the same direction until a force is applied and the direction of motion is changed. So these are the three kinds of inertia that are present in a body. Okay. Now we will be discussing some practical examples. See, you must have been riding on train or moving in train. You must have gone to many places by traveling in train. Okay, so when you are traveling in train, you must have noticed one thing is that when the train is at rest, say it is standing at a station, you sit on the seats, and then the train just starts to move suddenly. As the train starts to move suddenly, what happens? You feel a jerk, isn't it? And it looks like as if the lower part of the body moves forward a little bit, and we tend to lean back a little bit. This is why this happens. This is because this can be also felt more accurately if you are standing on the train. Okay, you are standing on the train, you are not sitting, and the train is at rest. It suddenly starts moving. It starts to move out of the station. It starts moving, and you suddenly feel a jerk. You feel that as if your legs have moved forward a little bit, while your upper part of the body tends to lean back. Why this happens? This happens as because our lower part of the body, when it is in contact with the floor of the train, what happens? As soon as the train comes in motion, the lower part of your body, which is in contact with the floor of the train, also comes into motion. But due to the inertia of rest, the upper part of the body is still at rest. It is trying to remain in its state of rest. That is why instantly we feel that the upper portion of our body tends to go back. Actually, it is not going back. What happens is that lower part of our body has moved forward a little bit, so we tend to lean back. Okay, so this is an example where the inertia of rest comes into play and the impact can be felt. Okay, Now, another example, if you want to give from the inertia of motion, so just the reverse, think just of the reverse condition. You are standing in a train, the train is running at a very high speed, and suddenly the train starts braking. It is time to come at rest. It starts braking, and after a certain time it comes to rest. As soon as the train starts to brake, what happens? A jerk is felt, okay, and your body, what does it move? What does it feel like? That your upper part of the body has moved forward, and we tend to just move or lean forward, isn't it? Or you tend to fall down. This can be felt more accurately while you are traveling in a, say, bus. You are standing in a bus which is running at a very high speed. It suddenly brakes. Okay, it suddenly brakes, and you are standing. So as soon as the bus brakes, what happens? The lower part of your body that comes into rest along with the bus, but the upper part of the body is still in motion due to the inertia of motion, and as a result the upper part of the body tends to lean forward and we tend to fall down. Okay, so these are the two examples. So we have discussed one example of a train starting from rest and we tend to lean backward, and the second example that we discussed is the fact where a bus running at a high speed suddenly comes to rest, by braking. What happens? A person standing tends to fall down. So person standing tends to fall down. Okay, tends to fall down. Okay, tends to fall down. So these are the first example is where the inertia of rest comes into play. Second example is where inertia of motion comes into play. Okay, fine. Another example where we can give or describe about the inertia of direction. Okay, so what example can we talk of? Practical example. All of you must have ride bicycle. Okay, so when you ride a bicycle, you must have noticed that when a bicycle moves, it tends to move in the direction in which the handle is pointing. It tends to move in the straight direction. In order to there was a interruption in the power. Sorry for the interruption. Okay, so while you are riding the bicycle, you see, when you try to change the direction of the bicycle, you need to apply force on the handle. Then only the handle of the bicycle moves and the direction of the bicycle can be changed. So changing the direction of a bicycle, is an example where inertia of direction comes into play. Okay, so these are the three examples. There are many more examples. You can take a glass of water and describing another one example. You can do this practically in your home, or you must have played carrom board. Okay, so while playing carrom board, what happens when you hit the striker and the striker hits the other buttons in the carrom board? Okay, what happens? Those buttons actually tends to remain in the rest, in the position of rest. Only those buttons that the striker hits, okay, that only tends to move. Okay, so the coin that are placed in the carrom board, okay, they tends to move only those coins which the striker hits. Okay, so basically these are examples of where the inertia of motion and inertia of rest are coming into play. So another example that I was going to say, you can take a cardboard and a coin placed over it and keep it over a glass of water. If keeping this arrangement, if you very quickly or with a very high force hit the cardboard, you see what happens. The cardboard just slips down the coin or slips to the coin, and the coin falls into the glass of water. The coin does not move. So what happens here? When you very swiftly make a strike at the cardboard suddenly comes into motion. The coin, due to inertia of rest, tends to remain at its position of rest, and it falls in the glass of water. So these are the examples where we can see that the inertia of motion or inertia of rest comes into play. Okay. Next thing that we are going to discuss is the linear momentum. So what is linear momentum? Now this is an important property, linear momentum. It is, say, when a body having a certain mass is moving with a velocity, say a certain velocity v, then the linear momentum for the body can be described as the product of the mass and the velocity. Okay, so linear momentum is defined as a product of mass and velocity. So linear momentum is generally denoted by the letter P, is equal to the product of mass and velocity. So if we talk of the unit, SI unit of linear momentum, what is the SI unit? Basically, its SI unit is kg meter per second. Or if we talk of the series unit, then it is gram centimeter per second. So these are the two units. So linear momentum, as you know, velocity is a vector quantity. We have discussed about scalar and vector quantities in the previous class. As you know of vector quantity, so linear momentum, since velocity is a vector quantity, okay, hence linear momentum is also a vector quantity. It has a direction. And what is the direction? Direction of the velocity gives the direction of the momentum. So this is linear momentum. Okay. So why we are talking of this linear momentum? Because actually when we will be describing the Newton's second law of motion, it involves the momentum. So another thing that I want to tell you and conclude the class is that what do you mean by rate of change of momentum? Basically, when momentum of a body changes in a certain interval of time, then it is said to be rate of change of momentum. So rate of change of momentum can be written like this. So if the change in momentum is delta p, this delta triangles and delta indicates a change, and it changes in a certain time interval delta d, the rate of change of momentum is given as delta p by delta t. Okay, so this is the rate of change of momentum. Okay, with that we come to the conclusion of this class. In the next class we will be talking of the Newton's second law of motion. Please till then do study well. If you have any query, mention in the comment box. We will be happy to solve your problem. Thank you. Goodbye.